how are you? I hope you all are doing great today. My name is Renu Rathi and today we will be learning our very interesting and a very relatable topic, that is factors and multiples. In this chapter, we will learn about, let us do what we have done in the earlier classes: factors, common factors and highest common factor, multiples, common multiples by division and least common multiple, multiples of 2, 3 and so on up to 10, what are prime, composite, co-prime numbers, prime factorization, and we will learn LCM and HCF by prime factorization. Now let us do, we have to color the numbers that have only 2 factors in green and the numbers have more than 2 factors in red. Now the numbers that have more than 2 factors, we have to color them in red. So that is 24, we can color it, 42, we can color it in red. That's how you have to complete all the numbers by coloring. Next is factors. Now we know that when a number divides another number exactly without leaving any remainder, that is called the factor of the second. Now 6 5s are 30. Now 30 is a multiple of 6 and 5 and 6 and 5 are the factors of 30. Now here 60 is a multiple of 3, 4 and 5 and 3, 4 and 5 are the factors of 60. Similarly, 5 and 9 are the factors of 45 because 5 9s are 45. 8 and 9 are the factors of 72 because 8 into 9 is equals to 72. And 2, 3 and 5 are the factors of 30 because 2 3s are 6 and 6 5s are 30. Now when we multiply any 2 or more numbers, we get a product, and the product is a multiple of each of the number that is multiplied, and each number is a factor of the product. Now let us find the factors of 12. 1 divided by 12, 0, 2 remainder 0, 3 remainder 0, 4 again remainder 0 and 6 again remainder 0. So that means the multiplication factors of 12 are 1, 12, 2, 6, 3, 4. So when we arrange all the numbers, then the factors of 12 are 1, 2, 3, 4, 6 and 12. Now, thus if a division sum, if the remainder is 0, then the factors of the dividend are 1 and divisor and the quotient. So 1 is a factor of every number, you always have to keep that in mind. 9 divided by 1 is equals to 9, and the greatest factor of a number is the number itself. Now for example, we have to find the factors of 6. Now 1, 2, 3 and 6, and we know 6 is the greatest factor. So here we are making dots and find the factors of 21 and 33, that you have to try it by yourself. Now here 1 into 21 is 21, 3 into 7 is 21. Now here we have 1, 2, 3, 1, 2, 3, 1, 2, 3. 3 dots of 7 groups each. Here 7 3s are 21. That's how you can complete the remaining part. Next is our common factor and highest common factor. Now common factor and highest common factor. Now we will consider the two numbers 6 and 9. Here are the factors of 6, here are the factors of 9, and the common factors are 1 and 3. We will take another example, that is factors of 12 and 24. Here are the factors of 12, here are the factors of 24, and the common factors are, that is 1, 2, 3, 4, 6 and 12. Now 12 is the highest common factor, so the HCF of 12 and 24 is 12. Now if we have to find the HCF of two numbers, that means the smaller number is a factor of the greater number and the smaller number is also the HCF of the two. Now for example, between 12 and 24, 12 is a factor of 24, hence it is the HCF. Now let's understand it better with the help of example. We have to find the HCF of 9 and 12. Here is the factors of 9, here is the factors of 12. Now factors of 9 are 1, 3 and 9, factors of 12 are these one. Now the common factors are only 1 and 3. Now HCF of them among 1 and 3, which one is highest? Larger number 3. So 9 and 12 HCF is 3. Now let's look at example number 2. We have to find HCF of 10 and 15. Here is the factors of 10, here is the factors of 15. Now common factors are 1 and 5. Now the HCF is 5, as 5 is the highest common multiple. Now in example number 3, we have to find HCF of 9 and 16. Here are the factors of 9, here are the factors of 16. Common factors are only 1, so the HCF is 1. Now in next example, we have to find the HCF of 42 and 48. Here are the factors of 42, here are the factors of 48, and the common factors are 1, 2, 3, 6 and the highest of them is 6, so the HCF is 6. Now in the next one we have to check if 11 is a factor of this number or not. Now for checking it, firstly we will divide this number, and after dividing it we know that the remainder we get is 0. That means this number is a factor of 111. Now in the next one again we have to check whether 17 is a factor of this number or not. Now after dividing it we can see that we have the remainder 1, and if a number having a remainder, that means it is not completely divisible and it is not a factor of that number. So that clearly means 17 is not a factor of 1208. Let's start with exercise 6.1. In the first bar we have to choose the correct option and fill in the blanks and fill the OMR sheet correctly. Now 2 is a factor of 12. First one is the correct answer. That's how you can solve the remaining part. In the next one we have to write true or false. What is exactly divisible by 20? True. In the next one we have to find the factors of the following. 12 factors will be, that is 1, 2, 3, 4, 6 and 12. That's how you can complete the remaining part. Now we have to write yes or no. Is 2 is a factor of 21? No. In the next one we have to list the common factors and find the HCF. 9 common factors will be 1, 3, 9. 1, 3, 5, 15. So the common factor is 3 and the HCF is 3. That's how you have to complete the remaining parts by yourself. In this one we have to circle the number which is the HCF of the following pairs. So 10 is the HCF among 10 and 30. In the next one we have to check by division whether this number is a factor of that number or not. So when we divide it, 1776 when divided by 6, it becomes 6 2s are 12, 7 minus 2 is 5, 57, 6 9s are 54, 7 minus 4 that is 3 and 6 6 are 36. So yes, 6 is a factor of 1776. That's how you can complete the remaining part. Now next topic is our multiples. Now when we multiply 2 or more numbers we get another number, and that is called the product. The product is a multiple of these numbers and which is called the multiplier. Now multiple means a number of times. For example, 6 into 7 is 42, that means 7 times 6 is 42. So 42 is a multiple of 6. Again we know that 6 times 7 is 42, so 42 is a multiple of 7 also. So when a number is multiplied by 1 we get its first multiple, and when the number is multiplied by 3 then we get the second multiple and so on. So multiple of 3 here is the first multiple, second multiple, third multiple, fourth and fifth multiple, that is 3 into 5s are 15. Now here are the properties of some multiplication fact, that 0 is a multiple of every number, because 0 multiplied by any number gives us as 0, and every number is a multiple of 1. As 1 is multiplied by any number, it always gives the same number itself. Now the first multiple of every number is the number itself, as when we multiply the number by 1 we get the number itself. The multiple of a number are either greater than or equal to the number, and the multiple of number can be divided by the number without leaving the remainder. For example, 16 is a multiple of 4, so the remainder is always 0. 64 is a multiple of 8, that means the remainder is 0. Now let's start with exercise 6.2. In the first part we have to fill in the blanks. In 4, 8 are 32. 32 is a multiple of 4 and 8. That's how we can complete the remaining part. Now in the next one we have to find the first 5 multiples of the given numbers. So 5, 10, 15, 20, 25, 30. In the next one we have to take the multiple of the given numbers. So 5 multiples are, that is 15, 30, 45. That's how you have to complete the remaining part. Now in the next one we have to fill the 5th and 15th multiple of the following. So 3 5s are 15 and 15 3s are 45. So 7 5s are 35, 9 5s are 45, 6 5s are 30. That's how you have to complete it. Now checking multiples by division. Now in any multiplication sum, the product is also the multiplication of the number that is being multiplied, and therefore to find out if the number, let's suppose the number is x. Now if a multiple of the other number, let's say it is y, now when we divide x by y, if there is no remainder, that means it is a multiple. Let's understand it better with the help of example. Is 20 a multiple of 4 and 5? Now 20 divided by 5 and 20 divided by 4, we know that without leaving a remainder, yes, both are multiple of this number. Now we have to find whether this number is a multiple of 9 or not. So when we divide, 9 9s are 81, yes, it is a multiple. Now is 21 a multiple of 3 and 5? Now when we divide 21 by 3, it gives 0 remainder, but when we divide it by 5, it gives 1 as our remainder. That means 21 is a multiple of 3 but not a multiple of 5. Now let's look at even and odd numbers. So even numbers, a number which is a multiple of 2 is an even number. For example, you can see the shaded columns, all are the exactly divisible by 2 and are even numbers. Now for the odd numbers, the numbers that are not divisible by 2 are called odd numbers. In other words, odd numbers are not exactly divisible by 2. These all unshaded columns are our odd numbers, and here are our table of odd numbers and even numbers. Next is our common multiple and least common multiple. Let's start with the common multiple. We have written the multiples of 5 and the multiples of 10, and here are first few common multiples of 5 and 10 in the colored circle. So the common multiples are 10, 20, 30, 40 and 50 and so on. Now let's start with the least common multiple or LCM. Out of these 4, 10 is the smallest or least common multiple or LCM of 5 and 10. The next 3 common multiples are 20, 30, 40. Now here are the properties of LCM. LCM of 2 co-prime number is their product. LCM of 2 or more than numbers cannot be less than any of them. If a number is a factor of another number, then their LCM is the number itself. Now let's find the LCM or least common multiple with the help of example number 6. We have to find out the LCM of 3 and 5 from the given set of numbers. Now firstly we write the multiples of 3. Here we wrote in the chart. Here are the multiples of 5. Then the common multiples are 15 and 30, and LCM of 3 and 5 is 15. Now let's understand example number 7. We have to find the LCM of 3 and 4. Here are the multiples of 3, here are the multiples of 4, and here are our common multiples of 3 and 4. So the LCM is 12. Next is our example number 8. We have to find the LCM of 9 and 12. Multiples of 9, multiples of 12. Common multiple of 9 and 12, our least common is 36, so LCM is 36. Similarly, in example number 9, we have to find the LCM of 2, 3 and 4. Multiples of 2, multiples of 3, multiples of 4. The common multiples are 12, 24, 36. So 12 is the least common multiple, so this is the LCM. Let's start with exercise 6.3. In the first part, we have to form multiples of the following odd numbers: 3, 6, 9, 12, 15, 18, 21. That's how you can complete the remaining part. In the next one, we have to form the multiples of the following even numbers: 6, 12, 18, 24, 30, 36, 42. In the next one, we have to test whether the numbers are the multiples of the given number or not. Is 35 a multiple of 2? False. That's how you can complete the remaining part. In the fourth one, we have to find the least common multiple of each pair of numbers and also write the next 3 common multiples. Now 3, 6, 9, 12, 15, 18, 21 and so on. 4, 8, 12, 16, 20, 24 and so on. So the LCM will be right, it's 12. That's how you can solve the remaining part. Now in the next one, we have to find the first 5 multiples of the following, that is 7, 14, 21, 28, 35, 42. That's how you can complete the remaining part. In the next one, we have to find whether this number is a multiple of 6 or not. So yes, it is a multiple of 6. Now in the next one we have to find the LCM for these set of 3 numbers. Now 4, 6 and 8 we have to find the LCM. So here is our 4, here is our 6 and here is our 8. We have to find their LCM. So let's write their multiples, that is 4, 8, 12, 16, 20, 24, 28 and so on. 6, 12, 18, 24, 30 and so on. 8, 16, 24, 32, 40 and so on. So which one is the common? That is 24, 24, 24. So the LCM of all these terms is 24. That's how you can solve the remaining part. Now next is our multiples of 2, 3, 4, 5, 6, 9 and 10. Now any number that is divisible by another number, if it leaves no remainder, we can check it by divisibility test whether a number is divisible by another number or not. Now let us see the rules of divisibility 2, 3, 4, 5, 6 and 10. Divisibility rule of 2, all even numbers are divisible by 2. Here are the even numbers that are divisible by 2. Divisibility by 3, if the sum of digits are divisible by 3, then means the number is also divisible by 3. 27, 9, 81, 9 divisible by 3. Yes, the number is also divisible by 3. Next is divisibility by 4. If the number formed by tens and ones digit is divisible, that means the number is also divisible. If 12, yes, 12 is divisible, that means the whole number is divisible. Divisibility by 6, if a number is divisible by 2 and 3, that means number is divisible by 6. Divisible by 2, divisible by 3, yes, that means the number is divisible by 6. Divisibility by 5, if a number are ending with 0 or 5, that means it is divisible. Ending with 5, 5, 0, 5, yes, all are divisible. Divisibility by 10, if a number ending with 0, that means it is divisible by 10. Ending with 0, 0, 0, yes, they are divisible by 10. Next is divisibility by 9. If the sum of digits of the number is divisible by 9, then the number is divisible by 9. 9, yes, 9 again, yes, they are divisible by 9. Now let's start with prime and composite numbers. One has only one factor and that is itself, it is called a unique number. Now numbers having only two factors, that is 1 and the number itself, are called prime numbers. Now examples of prime numbers are 2, 3, 5, 7, 11. Numbers having 3 or more factors are called composite numbers, and the examples of composite numbers are these. So these are the numbers, these are the prime numbers in circle, and all the other numbers are our composite numbers as they have more than 2, that is 3 or more factors. Now how we can find prime and composite numbers from 1 to 100? A shortest method is given below to find out the prime numbers between 1 and 100. Step 1 is cross out 1. Step 2, you have to cross out all the even numbers except 2. In step 3, you have to cross out all the multiples of 3 except 3. In step 4, you will cross out all the multiples of 5 except 5. Then in step 5, you will cross out all the multiples of 7 except 7. Then the numbers which are not crossed out are prime numbers, and the crossed out numbers are composite numbers except 1, which is a unique number. 1 is neither a prime number nor a composite number, and these all are our prime numbers between 1 to 100, and the crossed ones are the composite numbers. Now let's start with twin prime numbers. Prime numbers whose difference is 2 are called twin prime numbers, simply twin primes. For example, 3, 5, 5, 7, 11, 13, 17, 13, difference is 2, that means they are twin prime. Next is co-prime numbers. For example, we have to find the HCF of 7 and 11. So the HCF of a pair of numbers is 1, and the numbers are called co-prime numbers. Two consecutive numbers are always co-prime. Two prime numbers are always co-prime, but co-prime number need not to be prime. Now for example, we have to find the HCF of 25 and 27. The HCF is 1, so that means they are co-prime but not prime numbers. Now in the fourth one, a prime and a composite number will go co-prime except when the composite number is a multiple of prime numbers. For example, 7 and 28 or 11 and 22 are not co-primes. Let's start with exercise 6.4. In the first one, we have to underline the numbers which are divisible by the circled number. So, 78, 156, 340. That's how you can complete the remaining part. In the next one, a number is divisible by 10 if it ends with 0. The next one is we have to answer the following. Write the smallest prime number, that is 2. Now next is the project work. You have to write your birthday date, 1 or 2 digit number, whatever it is. Then you have to observe its multiple factors, whether it is an even number or odd number, it is a prime number or composite number. Now let's start with the prime factorization. There are several ways to factorize the number. We have to consider the factorization of 36. Here is our prime factorization of 36. Now we have to find which factors are now prime numbers. Now 2 into 2 into 3 into 3 is the prime factorization of 36. Any factorization having each factor which has each factor as its prime number, that is the prime factorization of a number. Factorization of a number ends when we reach a prime number, because a prime number cannot be factorized further. Now finding prime factors of a number, we can do the factor tree method or division method. Now let's understand it with the help of a factor tree method. With example number 7, we have to find the factors of 12. So consider 12 as a base, then write one pair, that is 2 into 6. After that, check 6 is a composite number, then we will factorize the term 6 till it reduces to the prime number. And here is our factor tree of 12, that is the prime factorization of 12, that is 6 into 2, or 6 can be written as 2 into 3, or we can write it as 3 into 4, and 4 can be written as 2 into 2. So this is the prime factorization of 12. Now prime factorization by division method. Let's start with the working rules. First one says that we will divide the smallest prime number that divides without a remainder. Then we will divide the quotient, again a prime number, and we will repeat the process using only prime numbers till the quotient is 1. Then the product of all the prime factors divisor is the answer. For example, we have to find the prime factors of 24 and 20. Now firstly we divided by 2, again 2, 2, then 3 till it reaches 1. We reaches 1, that means this is a prime factorization. Again if it reaches 1, that means it is a prime factorization. Now finding LCM by prime factorization. How we can find LCM by prime factorization? The LCM of two numbers is the product of prime factors of both numbers taking the common factor only once. For example, we have to find the LCM of 12 and 30. Now in example number 10, we have to find this. Now solution is, firstly we will find the prime factors of 12 and the prime factors of 30, and we will always start with the smallest prime number, that is in this case which is 2. After that again 2 and then 3. In this case it is 2, 3 and 5. Now we will take only the common factors which are prime, that is 2 and 3. So 2 into 2 into 3 into 5, that is 60 is our LCM. Now finding LCM by common division method. In this one we have to divide both the numbers by a common factor, and we will write the quotient below these numbers, and we will repeat the process till we get numbers having no common factor. Now the product of all the divisors and the numbers left in the last row is the required LCM. For example, here we have done it by the division method. Firstly we divided by 2, then by 3, and this is 2 into 3 into 2 into 5, that is 60. Here we have 2 into 2 into 3 into 8, that is 96 is the LCM. Now always remember, when the number cannot be divided by common factor, we will stop dividing. Let's start with exercise 5.6. In this one we have to find the factor tree, and we have to find the prime factorization of both the numbers. So we have to find for 36. 36 is 6 into 6, then 2 and 3, and here we have again 2 and 3. That's how you can complete the remaining part. Now in the next one we have to find the LCM of these numbers. LCM of the numbers 8 and 12, that is 2 4 is 8, 2 6 are 12, again 2 and 3. Now this is our LCM. Our LCM is 2 into 2 into 2 into 3. This is our required LCM. That's how you can complete the remaining part. Now next is Finding HCF by prime factorization, we have to find HCF of 2 or more numbers, that is the product of the common prime factors of the number. Now let's understand it better with the help of example number 13. We have to find the HCF of 14 and 28. Here is the prime factorization of 14, here is the prime factorization of 28, and here are the common multiples of both the numbers, that is 2 into 7. So 14 is the HCF of 14 and 28. Now finding HCF by common division method. In this method, we will divide both numbers by a common factor and we will write the quotients below these numbers. Then we will repeat the process till we get numbers having no common factors. Then the product of all the divisors is the required HCF. For example, we will divide 18 and 24 by 2, then by 3. Now 3 and 4 has no common factor, so it can't be divided further. So 2 3s are 6 is our HCF. Now let's start with exercise 6.6. In this one, we have to find the first and second part. We have to find the HCF of the following terms by the prime factorization method. Now firstly, we will do it for 72 and 81. So for this, firstly 3 2s are 6, 3 4s are 12, 3 2s are 6, 3 7s are 21, again 3 9s 27, 3 8s are 24. So that means 339 is our HCF. That's how you can complete the remaining part. Now next is in third and fourth, we have to find the LCM by the prime factorization method. So for 8 and 12, we have to find the LCM. So that is 2 4s are 8, 2 6 are 12, again 2 and 3. So the LCM is 2 into 2 into 2 into 3. Now let us summarize what we have learnt earlier. The greatest factor of a number is a number itself. 1 is a factor of every number. The multiple of a number is either greater or equal to that number. A number is multiple of 2, it is called an even number. A number not a multiple of 2, odd number. All even numbers are divisible by 2. One has only one factor and that is itself, so it is called a unique number. Let's start with think tank. We have to take the correct answer. The prime factorization of 48 is, which one is the prime factorization? That is 2 2 4, 2 8, 16, 3 48. So this is the correct answer. In the next one, we have to write down the first 5 multiples of the following, that is 9 2s are 18, 9 3s are 27, 9 4s 36, 9 5s are 45 and 9 6s are 54. In the next one, we have to match the following column A. 35 is a multiple of 7. That's how you can complete the remaining part. Now in the next one, we have to find the prime factors of 30 and 56 that you have to find out by the factor tree method. Maths puzzle, we have to put the numbers in the corner, place in the Venn diagram, that is which is multiples of 5, that is 5, 10, 35, 60, 1. That's how you can complete the remaining part. Now next is mental math. Guess me. I am a number between 20 and 230. I am a divisible by 5. What number am I? Right, it is 225. That's how you can complete the remaining part. Now I hope you have understood the chapter pretty well. You just have to practice the exercise questions and don't forget to revise this topic again.